大家好，我是包瑞阳。It's truly my pleasure to be here, and I'm excited for you guys to get your hands on the software, and we can learn a lot about your different businesses throughout the day.
所以大家好，他是包瑞安，他这一句话可能念了很久了，昨天都没睡觉。开玩笑，那他是希望说，大家各行各业我们都可以互相做交流，在这一次的研讨会里面。
So now we're in Shanghai at the Green Arrow, which is important to understand is it's our largest simulation development and it's growing. So we're taking a lot of technology that has a large customer base and experience in the US and also in Europe, and we're now focusing our future direction really right here. It's becoming the new center of excellence for Autodesk simulation.
所以大家可能不知道，我们的研发大部分呢现在移到上海来了，尤其是仿真的产品，现在很大的一部分在上海。那为什么这样呢？因为大家看到这个区域的需要，就是原来在北美和欧洲这些仿真的技术已经趋于成熟，但是这个亚洲这边呢有很多不同的需要，所以我们把很多仿真的人才建立在这边，叫做一个优越中心就是客户实验的这个中心也在这里。
And then down in Australia, there's another development headquarters that where we have a test lab where we do a lot of validation of our software, so we can make sure we have great accuracy before introducing new functionality.
在澳大利亚墨尔本呢，我们也是有一个很大的中心原来是 Morpho 的中心，那现在变成全部仿真的这个验证中心所以有包含材料测试啦，然后那个力学验证的实验室都在墨尔本。
So my background really started in electronics cooling. I focused my master's degree on new product development and using technology to have distributed teams around the globe work well together. So I worked on a design for Philips where we had the electrical team in Germany. My team was in United States, and we teleconferenced back in 1999 to co-develop a product for them. And we did research in how to efficiently have multinational meetings using teleconferencing.
他的本身的专长是在电子散热的部分，他有16年的经验，他有硕士的学位是有关于产品研发。他最早是在那个飞利浦这家公司，不管在荷兰和北美这边，他都是有一个协同设计这个过程，所以他们是最早用这个电子会议这边来互相做这个协同设计和分析的一个 team。
So my specialties and my focus has always been, using CAD and CAE tools to help companies bring products to market faster, drive targeted research and development, and get the right balance between testing virtually with simulation and testing physically in test labs.
所以他在这个过程里面，其实非常强调，就是说我们到底有多少要用分析，有多少必须要用实际的测试，这中间其实需要一个平衡，对不对？我们不可能是完全用分析，然后不用测试，但是中间要互相要做验证。但他在中间呢，找到一个最佳的方法，在多少的份额是用来测试，多少应该要用分析，来节省这个测试的经费。
And now I work around the world helping companies reach those goals. There are companies from small startups to big international firms.
常常接触到不同的企业，有小的有大的那当然他们有不同的目标，但他认为我们的任务也都是把这些企业呢能够达成他们这个目标。
So I'd like to share an experience I had with simulation.
Hey Mark, take it over. 我应该会。他要分享一个他实际的一个案例。
下一个举手，谢谢举手。
I'd like to share an experience I had with simulation when working for Lutron Electronics. They make lighting control systems, both dimmers for your house, but also lighting systems for office buildings, casinos, restaurants. So this product right here, you have an on-off button. You can raise the lights, lower the lights, and then the LEDs tell you what level it's at.
是这样，就是 Run 呢，它之前呢，它是其实在那个就像我们的 building 的开关的，它有很多的设计经验，因为很多开关呢它是用塑料件来做的，所以它之前呢就专门来做，比如说像这种开关的话呢，就是它来做的，它在方面呢它有很多年的一个经验了。OK。
To design a light switch for a 10-year lifespan, it's going to be approximately 20,000 cycles of the button. So we wanted to make sure the design was going to last for 20,000 cycles. That's about 5.5 a day.
它的这个，比如说这个开关呢，它需要不断的开和不断的关，所以它相当于是一个cycle 的一个相当于不断的去开和关的一个经验。它这个方面呢，它已经是相当于要做有10年的一个经验了。
So looking inside this dimmer or lighting control, this part has a beam to push the on-off, and then it has a rocker that twists to raise and lower the light.
它这个呢，相当于是有这个开关，就是不断的摁和压的一个去把那个灯呢开和关的一个过程。
So as engineers, we focused on mechanical simulation. We cycled the part over and over again and had what we thought was a good design. So go ahead.
作为那个，比如说我们是机械工程师来说呢，就是我们那个通过不断的这种机械设计呢，去开和关这种设计呢，去优化我们的设计，来去找到我们最好的一个设计。
So then we built temporary tooling to make some prototypes out of molded plastic. And the thermal side of the problem, in lighting, when you dim a light, you generate heat. So we knew there was a thermal problem.
对于开关呢，如果说呢，其实它在热方面有些问题的，因为它如果说产生光的话呢，它会产生一些热量，所以它会产生一些，比如说一些散热的一些问题。
Right. But we simulated the mechanical problem, and we decided that we would just use physical testing to validate the mechanical problem worked when the electronics were heating up the system.
我们通过我们的那个机械仿真呢，去验证我们实际的那种物理模型，相当于我们做一个物理的验证的一个过程。
This product was a very high volume product for Lutron. It was a very important project. When this was put to market, after 3 months, 80% of the products came back because they failed. The plastic broke right where that red arrow is. And we were left embarrassed and confused. What did we miss?
当时这个设计的时候呢，其实有80%的那个，相当于它已经就是那个毁坏掉了。然后呢，他们就非常的就是迷惑的，为什么会出现这种现象呢？就相当于是这个产品的验证出来之后呢，它会失效的那个有80%左右。
So we thought we had a good virtual and physical test plan to build a reliable product. What we missed was that the thermal load isn't constant. So we heated up the dimmer and cycled it very fast. But actually what happens when you cycle it 5.5 times a day, it heats up and then it cools down. It heats up and then it cools down.
这个呢，其实这个开关呢，它实际相当于是一个增加了一个热的一个载荷，就是不断的去它的一个它的那个，比如开的时候呢，它可能会热的会增加，然后呢之后呢，它会热量会降低，相当于是这样的一个载荷的一个循环的一个过程。
So we were cycling on and off every second. After doing some more simulation work with CFD now, we're able to look at the cooling as well as the heat transfer in the mechanisms to identify that with took 30 minutes for the product to fully cool down. So after we adjusted the cycling to 30 minutes, the product failed after 300 cycles, not 20,000.
通过我们 CFD 的仿真呢，其实我们可以模拟它的整个的一个这样的一个过程，因为很多时候它是因为热产生的这个热应力， 所以说呢，我们通过我们的那个 CFD 的仿真，包括每克隆的仿真呢，去模拟它的产生失效的一个整个的全过程。
So from this design experience, which was quite an embarrassment, there was a few things that at Lutron we kind of decided that we learned. One of them is that simulation really is easy to use. You can simulate just about anything you want. It's a lot faster than doing physical testing. So you can make a lot of mistakes inside the computer and do abuse testing a lot quicker. And without exploring your design functionality in simulation completely, you end up taking shortcuts. And those end up being very dangerous to quality.
Run 认为呢，其实我们做仿真呢，其实是非常简单的，因为很多时候呢，我们通过我们自己的电脑呢，就可以模拟出来，因为它比我们用实际的物理模型呢要非常的快，而且呢，它那个比如说找到一些它的一些那个问题的所在呢，它其实非常非常快速的，所以这也是我们为什么认为我们的仿真是比较简单的一个原因。
The other thing that we all decided was design is what's hard. Designing quality products, designing innovative solutions is a real challenge. And just physical testing makes it take a long time, and you can't abuse test everything. So what our goal inside Autodesk, we're a design company. We have great design tools. We're now providing simulation tools for you to make your designs easier, faster, and more reliable in a virtual environment.
其实这个设计呢是比较复杂的，因为它一般来说呢，我们想设计一个好的产品是非常有挑战性的。另外呢，我们欧特克这个公司呢，我们提供了非常强大的这个设计的工具，同时呢，我们也提供了仿真的这种工具呢，去为我们的设计呢进行一个仿真的验证。
Okay. Going to switch my machine here so I can show you the product and do a demonstration. It's going to take me a second, so please be patient.
这边呢就是Ryan 想跟大家再秀一些其他的另外的一些关于行业方面的一些东西。
We have people in the room today that have that work in all different types of industries. And as you can imagine, I've been exposed to a lot of them. I have deeper experience in some than others. But one thing that I've learned over the years is that simulation speaks the common language of making, studying your designs and making them better. So what I wanted to show you is something that everybody can understand. We all work, live, and shop and eat inside in buildings. Buildings can be hot, cold. They can be comfortable. They can be uncomfortable. So I want to show you a demonstration of how simulation is being used to understand the ventilation systems and the solar loading from the windows. Because it can be, whether you're looking at airflow and heat in a building, or airflow and heat in an electronics box, or airflow and heat in a valve, the workflow is very similar. But how you set the model up is different. And when you go through the workshop today, you'll learn the setup for your specific industry. So just imagine with me, you're building this room.
这个呢，它其实是一个房间的一个案例，因为很多时候呢，我们每个人他是在我们的工作呢都在不同的这种行业的房间里面工作的，所以说呢，我们的 CFD 呢，我们可以提供一个模拟，相当于在 AC 行业的一个模拟的一个平台，因为我们可以模拟它的包括它的热输入度，然后里面的气流组织，我们包括它太阳的一些辐射的情况，我们都可以加进来。这样的话呢，因为其实很多时候呢 ，CFD 它是比较相通的，因为无论是它的流动方面，包括它的整个它的一个热性能方面呢，其实比较相通的。所以说，我们想通过这个案例呢，想跟大家讲一下，然后大家可以通过自己的行业的不同的行业呢，去根据自己呢去完成一些比较简单的一些设置，比较简单的一些相当于走一些我们的 workflow， 来去感受一下我们的 CFD。
Okay. So in this room, we have Mark Ma sitting on a bench looking at some really nice piece of artwork. And then up top is where the air supply comes in. And then down below is where the return is down at the floor. That's where the air leaves. Air comes in, air leaves. Inlet, outlet.
这个呢，它是一个相当于一个房间，然后这个假设是我坐在这个房间里，然后呢，因为我们可能要观察每个人的热输入度，所以说呢，一个人他坐在这个凳子上面，然后上面呢不同的这个口呢，它指的是送风进来的一个口，然后下面呢这个呢，它是一个出风口。Okay.
So where the heat comes from is we can model summer conditions and winter conditions. We can set up to be heating or cooling. We can look at the energy from solar loading, how much energy, and what the external environment is to match these things together. Just like if you're designing electronics for the military or electronics box, it's going to live in another system somewhere. So it breaks down the system. So we have heating or cooling, and then we also have the heat from people. People generate a good bit of heat. So the challenge is to design the ventilation system to cool the space uniformly in the summer and heat it up uniformly in the winter.
这个呢，它是其实我们建了两个，一个是相当于夏天的，一个是冬天的。然后呢，相当于一个人他是因为我们这里面有很多的它的一个热源，包括它的一个进风口的一个热源，包括一个人产的一个热量。然后呢，我们的挑战是呢，我们要设计它的通风系统，以保证就是我们在夏天呢，我们那个能让它比较凉爽，然后冬天呢能够比较温暖一点。
Okay. From any CAD tool that you use, whether it's ProE, SolidWorks, Unigraphics, Revit, Inventor, Autodesk is integrated with all the CAD tools and more so than simulation tools that are even embedded in CAD tools. So we bring in the geometry, recognize the materials that were assigned in that CAD tool, and then from that geometry, you can set up different test scenarios. In this case, a summer setup and a winter setup.
我们和很多的这种3D 软件呢，其实都有很强的一个接口。那无论是你的 Inventor 甚至包括建筑行业的这个 Revit， 我们都是有接口的。然后我们呢，它可以直接去在我们的3D 的软件里面呢，可以生成一个那种 plugin 的一个插件，然后直接去打开那个3D 软件的它的模型。然后呢，我们甚至可以把3D 模型里面的你们材料的一些设置，然后直接去无缝的去导入到我们的 CFD 里面去，来去进行一个仿真。
Okay. So let's look at some of the results. Simulation is always about looking at the invisible. Let's be able to visualize the air, visualize the heat. Now it's just like any other solid or mechanism that you built. You can learn how to optimize it once you can visualize it.
在这个里面呢，其实我们通过我们的 CFD 的这种模拟呢，我们可以把这种热呢通过可视化的形式来表示出来。然后呢，我们通过改进我们的设计呢，去优化我们的设计，通过我们这个模拟的结果去优化我们的设计。
So right away, put a plane right where the individual is, and we can see what the temperature looks like. It's around 70 Fahrenheit. We can switch to units to Celsius, make it a little bit easier for everybody. There we go. So this room is varying between 22 and 24 degrees. Sounds pretty good. We have hot areas, we have colder areas near the glass. But now you can take this plane and just start to drag it up. As soon as we get up to head level, it gets above 24. This could be looking at an electronics box, trying to determine where are the hot regions and the cold regions. How do you isolate temperature-sensitive components from heat-generating components?
它这个呢，其实它这个面是一个温度场的一个分布的一个面，然后我们可以非常非常快速的通过我们去拉扯这个面呢，然后我们可以得到不同平面上它的一个温度场的分布。然后刚刚呢，其实我们看到我们往上拉的话呢，它的温度是逐渐升高的。它其实有点像那个，比如说像一些电子箱，比如说我们电子散热里面的，其实它的基本原理应该是一样的。
So that starts to give you some gradients. Now we can look at flow direction. Visualizing flow direction starts off looking at 2D, but you can get even deeper to understand what does the three-dimensional flow look like. So we're going to create what's called an isosurface, which is going to make a surface in the results that has the same value of velocity. So you see how the air comes in here. We're in the winter, so the air coming in is hot. Let's hide that. So you see the hot air starts to rise.
对，我们这个呢，它这个面呢，它是一个相当于是一个平面上一个速度场的一个分布，速度矢量的分布。同时呢，它其实现在显示的呢，它是一个等值面的一个分布，就是我们可以显示，比如说它那个速度是一样的一个平面，我们可以通过这个拉扯这个它上面的一个 bar 呢，我们可以把它显示出来。
So these isosurfaces allow you to drag it through the model and understand what regions of the model in a 3D environment have hot air and cold air. And go ahead.
我们通过这个等值面呢，我们可以通过3D 的来去感受到我们那个它的一个哪个地方呢，它是比较热的，然后哪个地方呢是比较凉的。
If we make a temperature isosurface, you can do the same thing. Figure out where the hot air is and where the cold air is. So you're looking at either where do you have fast-moving air, where do you have slow-moving air, where do you have high temperatures, where do you have low temperatures. And here you can start to see the hot air rising off of Mark sitting on the bench.
它这个呢，其实是就是我们通过等值面呢，我们一方面可以知道温度哪个区域温度是比较高的，然后哪个区域呢温度是比较低的，哪个区域呢那速度是比较大的，然后哪个区域速度是比较小的。这个呢冬天的话，因为它可能是它吹的是热风嘛，所以说在进风口那个地方呢，它的温度，它一个区域的温度是比较高的。
On top of the isosurface, you also have the option to start putting the vectors back in place. So not just showing you where the temperature is, but what direction is the temperature heading. Go ahead.
这个呢，它是一个相当于是一个热流场的一个分布，就是我们通过这个呢，我们可以知道这个热呢是从哪个地方去。因为我们这个可以追踪热的方式，从哪个地方去到哪个地方来进行加热的一个过程。这个呢，也是通过我们的一个等值面来可以清晰的来看到一个3D 的一个图像。
So again, we see the hot air rising, hitting the ceiling and following it. And then by looking at the cold temperatures, you get to the outside of the building, where in the winter, the temperature is colder, so the air starts to drop.
刚刚那个热的空气呢，因为它是往上升的，所以我们可以看到它的一个流动的方向。然后呢，因为冬天的话，冷空气呢它是往下降的，所以说我们可以通过这个呢，它的矢量图也可以看到它的一个变化的一个方向的一个过程。
All right. Finally, we've looked at temperature gradients, velocity gradients, surfaces of temperature, surfaces of velocity. We can take it one step further to understand what does the flow traces look like. So we want to track air particles or dust particles in our system to find out where they go.
刚刚呢，就是我们展现了它的一个速度场、温度场的一个分布，甚至它包括它的一个等值面的分布。然后呢，接下来我们会演示一下它的一个比如说在那个出风口它流线的一个分布。
So at the inlet here, let's try this. There's a lot of ways you can introduce traces into your model. I'm going to start by just creating a 12 by 4 grid.
有很多方法呢，我们可以去展现我们的一个流线的它的一个，因为现在我们想制作一个流线的起始端，所以这个时候呢，我们就是通过我们生成一个网格的形式来去展现，就12×4的一个网格形式。
Now the airspeed starts to come to life a little bit. You see the same type of trends where the air is going along the roof to the bottom, but now you're identifying where flow is recirculating. So this area in the room, the flow is just kind of trapped. It's in the corners. It may be important and may not, but that often leads to hotter components, or it can lead to increased pressure drop inside a valve.
通过它的一个流线的分布呢，其实我们可以看到它从上面流进来，然后往下面来流出的过程。然后呢，它在角落里呢可能会产生一些漩涡的情况。然后通过这个呢，我们可以比如说判断一些压降的一些情况呢，我们可以去知道我们的一些设计方面的一些处理。
All along the way, when you build these different images, you can either save them as a summary so you can compare them later, we'll get there, or you can save the view settings. So if you want to go back to one you worked on before, you can just pull it up and have a different trace. So focusing on where that recirculation was happening, you could put a point in that recirculation zone, and the software will back calculate where it came from. So if you look at a cooling design that has multiple inputs and multiple outputs, knowing where the flow goes, which outlet does it go to, is impossible to see in a physical test, but you can point right to it within simulation.
通过这个仿真呢，其实我们也可以生成一些动态的一些图像，比如说这个图像，我们呢就是我们选取它可能会产生这个回流的它的一些流线，然后呢来进行单独的这个显示。但是呢，这个呢，比如说在我们的物理的测试中呢，我们是看不到它真实产生这种流线的过程，所以说这也是我们仿真的一个目的和我们仿真比我们真实的物理的测试的一个优势。
All right. In the end, what's most important in the built environment space is comfort. And we look at that as % person dissatisfied. So if we set the scale here to this person, it's telling you by colors that you're only going to have 3 or 4 people uncomfortable in this space. %. So it scales it based upon the metabolism rate of the body, the person in the room. We can also look at what the thermal comfort is of the seat. That way, you can dial in the performance for the climate and location and the culture that you're working with.
我们这边呢可以显示一个相当于人的它的一个舒适，它的一个满意度的一个过程。然后呢，我们不但可以显示人他整体的一个满意度，因为这个百分比嘛，我们可以知道大概有多少人他是对这个温度是比较满意的，然后多少人对这个温度是不太满意的。同时呢，我们也可以看到这个 比如说这个凳子上面它的一个温度的一个满意度的一个过程，我们都可以通过这个来去得到。
We looked at a lot of nice pictures, quantitative results. Looking at one image versus another, it's easy to identify where good performance is and where improvements can be made. But there's also ways to get in and start to extract data on a qualitative approach or quantitative approach. So in this case, we'll just plot from the left side of the room to the right side of the room, and a graph is brought up that shows you what the temperature is across that line.
这个平面呢，因为它相当于是一个剖面嘛，然后呢，我们可以通过这个曲线呢，我们可以得到从这个点到那个点，它的一个温度的，随着它的一个距离的，它的温度的一个变化的一个过程，我们可以看到它的一个横坐标，它是一个距离的一个距离的量，然后它的纵坐标呢，它是一个温度的一个量。那我们可以通过这个呢，可以非常清晰的去表达出来。
The spike here in the middle, if you're curious, is again the body heat. The bodies are sometimes the hottest objects in the room, and they can affect the airflow if you have enough of them. When you're looking at the data across your trend line, you can switch to any parameter being solved for. So again, instead of looking at temperature, we can look at velocity. Is there a trend or correlation between the temperature and the airspeed? Here, the airspeed on this side is a lot hotter than this side because this side is a window and this is an internal wall. So just like in a building, windows will release energy, walls will contain them. So based upon your electronic design or thermal system, heat exchanger, how well it's insulated can really change the flow situation, and that all leads to inefficiencies. Velocity. Oh, yeah.
这个呢，就是它的一个线性的一个，在这条线上它的温度的一个变化的一个图形。然后呢，为什么中间突然出现一个突然出现一个增高点呢？因为在这个地方呢，它相当于人呢，它是有产生热量的，所以在这个地方呢，它的温度是升高的。所以我们可以通过这个呢来去判断哪个地方，比如说哪个地方呢，它的一个产生的热量呢是在哪个地方，然后它的一个整个沿着这条线上它的一个温度的变化的一个趋势。
Okay. Oh, yeah.
这个呢是它的，就在这条线上面，我们其实可以选择不同的它的一个变量来去显示。在这条线上面呢，它的一个速度的一个变化的一个过程。其实为什么说这边要比这边高呢？因为这边呢它有一个窗户，然后这边呢它是没有窗户的，所以在这边呢它的速度呢是逐渐的往升高，然后往下降的一个过程。
Great. So we just spent a good bit of time studying one room in one condition. And this room had one outlet. And we noticed that one side has a lot of airspeed and a little bit of energy loss. So the question is, can that be improved? But also there's a question, how does the system operate in the summer? So once you have one set of results, your design process has just begun. So the software is designed for you to scale very quickly. So through cloning, we can create other environmental conditions or materials, or we can bring in additional geometry from any CAD system. And in this case, we added another vent in the left side.
这个呢，因为它是首先这个是我们冬天的一个工况，然后呢，因为这边有个窗户呢，它是一个热量的一个耗散的一个过程，所以说呢，我们在想我们怎么去优化我们的这个设计。但是呢，我们如果说我们把这个窗户堵上的话呢，夏天这个工况的话呢，它就会非常不好。所以说我们这边呢，它有一个克隆的一个相当于克隆的一个命令，我们可以通过这个克隆呢，我们可以去来进行多工况的一个分析，甚至我们可以通过不同的设计呢，在我们设计软件里面不同的设计呢，我们可以得到我们不同设计的一个过程。然后等会儿呢，我们会在这个地方会打开一个窗户来去验证一下他们不同设计他们的结果的变化的一个过程。
So anytime you see data, whether it's a picture, a graph, you can capture it. Now what the software is going to do is gather all that data acquisition across all the different designs and scenarios that you create. This means we can go back to an isosurface. And we want to look at designs side by side. So when you create an image, all the designs now have a thumbnail down below. The data is extracted before you even look at the results live.
这个呢，其实我们可以去抓取一些图片来去比较不同工况下面它们变化的，它们之间有什么差异，我们都可以通过这个来去进行一个比较。因为很多时候我们是通过比较来去得到我的哪个设计呢是比较好的，或哪个工况是比较好的。然后这个呢是我们显示的是一个等值面的一个过程。其实我们可以通过把两个它之间联系起来，然后这样呢，当我们查看一个的时候呢，它另一个也会自动的根据你第一个的操作呢产生一些变化。
Now, in this environment, you're looking at apples-to-apples comparison, meaning that if I change the temperature legend in one model, on the left here, you'll see that this is a single return summer, and on the right is the dual return summer. So once we make that change, the software is going to update and adjust the legend to the dual return on the right, so you're always comparing the same color scale.
我们通过这两个它们之间连起来之后呢，我们通过改变第一个，比如说第一个它的一个它的这个 color bar 上面它的一个幅度呢，其实第二个呢，它也相当于是同时进行更改了。这样的话呢，我们相当于在同样的尺度下面来进行比较它们之间的不同，之间的差异。
So what's really interesting about this, again, we're trying to make this person comfortable. It could be the exact same thing trying to keep a power supply cool. Just by adding another vent, we've now entrained more cold air in the winter, cold air in the summer, so this person now has more cold air directly hitting them at a higher speed. That might be good, it might be bad. What's great about simulation is that you now know, and you can quantify that to make better design decisions with proper information.
通过这个比较，其实我们可以看到，我们在上面这个上面开了窗户之后呢，他这个人在夏天呢，他的明显感觉到比较凉快了，而且他身上的他的一个速度的变化呢也是比较大的。所以通过这个比较呢，我们就可以知道哪个设计呢是比较好，哪个设计是比较差的。
So beforehand, I created images here, so you can have access to any image that you look at initially to compare across different designs. Now you can begin to mix and match and put them together. So let's study this a little bit more. We want to look at the dual return summer and the single return summer. So you start to see, here's that drafty air hitting the back of the person, and here it's recirculating out the front. So you can start to study it a little bit different. And then in the built environment space, we can start looking at things like thermal comfort. And we notice that the dual return actually makes a person a little bit more uncomfortable because of that draft. They're actually a little bit hotter.
通过这个呢，我们其实可以生成一些，比如说一些变量，比如说是一些温度的变化，一些热输出的变化，包括一些它们的等值面的一些图形来进行比较。就是我们可以知道他在不同的这种条件下，我们哪个设计呢，他的个人的感受是最好的。比如说不同的设计，比如那个人的那个设计的话呢，他感受的热量呢是就是说他可能比较热一点，所以他的热输出度呢就没有这个好。这样的话呢，我们非常清晰的通过这个截取它们不同的图片呢，我们就可以得到不同的一个结果的一个比较。
So we think the single return is still a better design. So let's compare the single return with the vectors and look at winter versus summer. So in the summer, you see the cold air drops in and cools them off. In the winter, the hot air rises, to heat them up. So the flow fields are completely different depending upon the temperature range that you're in. So taking it away from the built environment and think about electronics cooling. The way a model runs at 0C and 120C is based upon the natural ventilation and the currents inside that product. Impossible to see. So it's really hard to understand if your airflows are being choked at the temperature range that you're designing your products to work in. So
它这个两个设计呢，一个是夏天的一个是冬天的。我们可以看到它的这个出风口，比如说冬天的话呢，夏天的话呢，它是出的凉风，所以这个风呢它是往下降的。然后呢，它在冬天的话呢，它是出的热风，所以说这个风呢它是往上升的。所以说它这个设计呢，其实和我们那个比如说电子散热方面呢是比较相像的。很多时候呢，我们就是通过这个它们不同的一个速度的这个它的变化呢，我们知道它里面它的一个温度场的一个过程。
So this leaves you with a dilemma. One design is better in the winter, one design is better in the summer. One design could be better in a hot condition, one design could be better in the cold. Which one do you pick, or do you try to find a third design?
其实这上面有两个设计呢，就一个是夏天的，一个冬天的。然后一个设计呢，可能在夏天是比较好的，然后另一个设计呢，可能冬天是比较好的。然后这个时候呢，就会产生一个问题，说是我们到底选哪个设计来作为我们最终的一个设计呢？或者说是否我们要进行第三个设计来去才能满足我们的要求呢？
Those graphs we looked at before can now be acquired from all the different runs too. So now we're looking at the temperature from the left side of the room through the person to the right side of the room. The blue colors are the dual return. The orange colors are the single return. The summer is the hotter ones of each. So just changing a return and supplying the same amount of air actually changed the mean temperature by 3 degrees. This is the most common design improvement that are made across industry, whether it's cooling, ventilation, valves. Changing the outlet can have a drastic impact upstream the way flow works. So right-sizing the outlet is the best way to improve your design. And a lot of designs are over-ventilated. There's too many outlets. That means the air is not as predictable and not as controlled. So putting the right size outlet in the right location gives you the highest efficiency.
这个呢，它是相当于是因为这边我们有相当于4个工况嘛，我们可以看到就是它刚才那条线的从这一端到另一端，它的一个温度的一个变化的一个曲线，然后中间那个比较高呢，就是因为当时有一个人他在那边进行加热的一个地方，所以说我们可以通过这个曲线呢，它的一个得到它的一个温度的一个变化的一个梯度变化呢，来去寻找我们最好的一个设计。
We're going to get started with the open lab, and we're going to show you 3 one-minute videos that just goes over the very basic workflow. The hardest thing to do in any new software is the first click. Where to go, what to do, how to navigate. So we'll play the video, but the instructions that you're going to follow take you step by step. If you get to a step and are confused, or you think you missed a step, ask one of us, because it's very common. Because it's something new for you to look at. By the end of the day, you'll be very fluent, very familiar with it, but this is a learning process.
接下来呢，我们会放3个案例，然后大家可以自己来去练习这个案例的一个过程。然后在这个案例中呢，我们会教大家怎么去设置一些简单的设置，然后怎么去跑这个 workflow。然后大家如果有什么问题的话，大家可以随时进行来提问。
Okay. So in the software, there's a field here that if you type in anything, any question you want, and hit the search button, it brings up our online help system right to that topic. A lot of our help system is translated to Chinese, not all of it. The models we're using today haven't been translated yet. They're new for the workshops, and they'll be translated soon. So once you get into the help system, we're going to use these quick start models. Under new user quick start, we'll hit the quick start model, and then you can close this tab, so we're not going to need it anymore. There's 3 models here: a valve, electronics box, and a room. Pick which one you want to work on for this first session. You can do more later, and we also have more tutorials that you can pick from in the next workshop. So let's just play one of these. We'll go right to the process.
好，这个呢是一个阀门的一个它的一个 video 啊，大家可以看一下这个，就是怎么它是如何去设置，一步步设置的，然后一步步去操作我们的软件。
This is if
The process begins with a CAD model and at least one flow plan. There are several ways to create a flow plan. You can create it in CAD. You can cap the openings, so simulation CFD creates it automatically. You can use fluid volume creation tools in Fusion. Or you can use the void flow tool in simulation CFD. In the second step, specify what you know about the device or system. Assign the materials, set the boundary conditions, and define the mesh. In the third step, run the simulation. The simulation runs in a series of small steps called iterations. When the results stop changing, the simulation is finished. In the next step, visualize the results. For these tools, you can understand how your device performs: vectors, traces, and plots, color shading and value outputs, isosurfaces, and more. In the fifth step, explore design alternatives. In many cases, you may want to explore different design concepts. Use the Decision Center to compare results and make informed design decisions.
we'll switch now from the process and get into the interaction basics. This is going to start to introduce how to use the mouse, the keyboard, just how to navigate the model.
You can use the mouse to navigate the model. To rotate, hold Shift and then the mouse button. To zoom, roll the scroll wheel. To pan, hold the middle mouse button. You can also use the navigation tools. Use the view cube to change the model orientation. Use the navigation toolbar for greater control. There are several ways to set the selection mode. You can use the Setup tab, the right-click mouse menu, or the Quick Access toolbar. To hide an object, hold Control while clicking the middle mouse button on the object. You can also use the right-click menu command. To show all parts, hold Control and middle click off the model. To change the model appearance, select from either the Quick Access toolbar or the View tab. To change the appearance of a part, right-click on it and select from the menu.
So we don't expect you to remember all that right now. The exercises will tell you which navigation step to use. It just gives you an overview of what your experience and options are moving forward. Now the last one here is going to go over the interface. Now this is what really differentiates us from most analysis tools. Coming from the CAD background, workflow and efficiency is so important. And later I'll share with you how Autodesk really develops workflows driven by use cases from people.
This is the graphics window. This is where you interact with your model. Here are some helpful tips. Left-click to open a context toolbar. Right-click to open a context menu. You can check your settings with the legend. In the ribbon, you can find just about any command you need. Here's some useful tips to help you get started. Use the Setup tab to define the model. Work from left to right. Use the Results tab to view results. Use the tools in any order. You can use the Setup and Results content to quickly access often-used commands. In the output bar, view status updates in the message window. Monitor solution progress on the conversions block. In the design study bar, an easy way to change the settings to right-click on it and click Edit. Let's discuss some design study terminology. A scenario is an individual simulation model. Design is one or more scenarios that use the same geometry. A design study contains one or more designs. You interact directly with the design study file. We can use the decision center to compare design iterations. Click a summary command to save an item from the current scenario. Simulation CFD automatically assembles the same data from the other scenarios. Manage summary results in the decision center. Compare data in the critical values tab. Compare results images in the design review center.
Okay, so I hope that's the last video we're going to watch. And they're there so you can watch them anytime you want. This is just on a website. Anybody can get to it, not just our customers. We're very open about our learning tools. So down below, step 2 is to do a quick start tutorial. You just start by picking which one you want to work on. And there's an overview. Here are all the different steps you're going to go through. Here's where people usually get stuck first. When you're ready, click here to start the tutorial. Very tiny little button there. When you click there, it gets started. There's videos here that have the same gentleman, Len Whitehead, who does our documentation and learning material. There's a video of him going through the steps. So you can sit there and watch him do all the clicks and picks that you're going to do if you like. Some people learn by watching very quickly. Some people like to learn by reading. So you can watch the video or skip it. And then down here it tells you exactly what to do. And when you get to the bottom of the page, there's a very, very small little next, just like the small here. And that takes you to the next step. And you keep working through until you get to the end. You can go forward and back from there.
这个模型它是一个那个伐木的一个小模型，然后呢，大家可以通过既可以通过那个我们的 video 来进行那个学习步骤来走，大家也可以通过把这个 video 呢就是忽视掉，然后通过这个一步一步呢我们去阅读来走就可以了。然后这个呢，我们整个这个支付系统呢，我们并不是只给我们的这个客户来用，我们其实很多人的话，我们都可以随便在网上我们都可以看到这个整个支付系统，只需要把这个 link 放上就可以了。
All right, so the easiest way to find this page, if you haven't found it already, is in the interface. Just click the little magnifying glass. You don't even have to type in help. It just brings it right up. And you go to New User Quick Start, and then you scroll down to the 3 models.
大家可以先进入这个 Quick Start 那个，然后大家现在打开这个嘛，然后进入这个里面之后呢，大家可以寻找3个这个案例，然后大家可以根据自己的就是我们自己的工作中的这个情况呢，我们可以自己来选择不同的案例来进行练习。
Some people like to use the instructions one behind and just switch between them. Other people like to minimize the instruction window to create more of a vertical ribbon on one side of the monitor. And then you can still switch between them like that. Or you can resize the interface to just work on the vertical ribbon to the right.